Okay, first see the function of these network type in OSPF. So let's say this is for point to point. Then we have broadcast. Then we have non-broadcast. Then we have point to multi-point. Then point to multi-point, non-broadcast, and then loopback and virtual link. Okay, here I am going to discuss about types of network. Let me change the color. Types of network type, we can say network type, and here I am going to discuss about the behavior means, let's say hello message also depends on network type. Today you are going to understand that. Then we have date time, date interval also depends on network type. After that, DR BDR election, DR and BDR election. Then we can discuss a neighborship, and then we can discuss dynamic neighbor. Done. See, okay, and okay, if my network type is point to point, when my network type is see, these are the network type. We have 7 types of network in OSPF. When my network type is point to point, that time, can anyone tell me hello timer will be what?
30 seconds.
Not 30 second, 10 second. By default, hello time on point to point network type is 10 second, and date interval is 40 second for time of hello timer. This is the same behavior on broadcast network also, like we are discussing last class. The hello timer and date time, maybe in any one class from the previous, we had discussed this hello time and date time on broadcast network. There was, hello timer and date time on broadcast network 10 and 40. Then okay,
Sir,
let me yes.
sir, it will be, sir, 30 only, sir. Point to point will be 30 by default. In broadcast, it is 10 and 40, sir.
In point to point, hello time is 30 seconds, sure.
Yes, yes, sir.
Okay,
I just checked the documentary.
okay. So here it will be, hello timer will be 30 second. Then hold on time will become what? If hello time is 30 second, then hold on time will become what? 4 time.
120. Yes.
So hold on time will be 120 second. DRE BDR election will happen on this link or not? On this network type? No.
No.
Here guys, we don't need DR and BDR. Okay, so DR BDR election will not happen when network type is point to point. And neighborship. Here can we configure a static neighborship? Guys, when network type is point to point, then we cannot configure a static neighborship. As we discussed in EIGRP, there was two type of neighborship, a static and dynamic. Here also in OSPF we have two types of neighborship. Till now we have discussed a dynamic neighborship. You will understand a static neighborship as well. Configuration is same like EIGRP. Okay, so OSPF neighborship also depends on OSPF network type. If network type is point to point, then we cannot configure a static neighborship. We can configure dynamic neighborship. Say yes over here. Okay. And just let me verify Nirav, it on broadcast link what is hello timer. I think it should be 10.
Broadcast, I'm sure, but for point to point,
How I can check hello time?
so IP protocols, I guess.
No. By running command show IP protocol, we cannot see hello timer.
Show IP interface.
See, so IP interface. Then
I think number, interface number.
1 minute, guys. Yes. So IP OSPF interface and then
Interface.
loop back 1 like this. Hello time is 10 second. Okay, Nirav, on broadcast when network type is point to point.
Okay, sir.
When network type is point to point, hello time is 10 seconds.
10,
So
40.
I was
Okay,
confusing.
okay.
Okay, so let me correct it again. Hello timer will be same like broadcast 10 second and hold on time
Okay.
will be 40 second.
Yes.
Okay, no problem. Okay, when network type is broadcast, then hello timer will be also 10
10.
second and hold on time will be 40 second.
40.
There will be no change. But DR and BDR election, here DR and BDR election will happen. Yes or no?
Yes.
Here DR and BDR is required. So yes, DR, BDR, yes. Static neighborship, we cannot form a static neighborship in broadcast network. Say no.
No.
And yes, dynamic neighborship is
Dynamic, yes.
Okay, when network type is non-broadcast. Non-broadcast. Then hello time is 30 second.
30
Then
seconds.
hello time is 30 second, brother.
Yeah, rest all. Yes, rest all will be 30.
Yes. Except virtual and loopback.
Okay.
Okay, so non-broadcast, whenever network type is broadcast, then hello time will be 30 second. You don't need to configure, automatically it will set hello timer will set 30 second and hold on time will become here 120 second.
120.
And in non-broadcast network also DR BDR election will happen. Yes. And static neighborship, yes brother, here we can configure static neighborship, but in non-broadcast network dynamic neighborship is not supported. Whenever network type is non-broadcast, then dynamic neighborship is not supported. We cannot configure dynamic neighborship. You will understand in which scenario you need to configure non-broadcast network. But whenever you will configure network type non-broadcast, hello time will be 30 second, hold on time will be 120 second, DR election will be, happen there, and you cannot configure dynamic neighborship. There you have to configure static neighborship. Then next type of network is point to multi-point. Whenever you have network type point to multi-point, then hello timer will be 30 second definitely. Hold on time will be also dead time 120 second. DR and BDR. Here also DR BDR election will not happen. Not required. Static neighborship, no, here we cannot configure static neighborship, say no. And dynamic neighborship, yes, here we dynamic neighborship is supported. And the last type of network is point to multi-point. So when network type is point to multi-point, then also hello time will be 30 second, hold on time will be 120 second, DR BDR election will not happen there, and static neighborship is supported, dynamic neighborship is not supported. Say yes and say no here. It not support dynamic neighborship. Is it clear? This is a chart. You can take a screenshot of it. This is no. Any confusion till here to anybody? No?
Sir, like I have confusion regarding this non-broadcast one.
Okay.
How actually the network looks like, because point to point it is clear, broadcast also it is clear.
I will show you
Point to
non-broadcast
multi-point.
also. Is it clear that what will be the hello timer, DR, BDR,
Yes,
and
yes.
static dynamic neighborship?
Yes, yes.
Let's discuss the scenario where we need to use these network type one by one. First, we will discuss point to
Okay.
point.
Okay.
Okay. Before that, I am telling you, if you want to change network type in OSPF, command is very simple. You will apply this command on interface. Let's say on interface F0/0, I want to change OSPF network type. So here I will run IP OSPF
IP OSPF
network,
network.
and then type of your network. Okay. This is command. Very simple. IP OSPF, here process also, process 1 and network, the network type. Here I can type what, broadcast, non-broadcast, point to multi-point, non-broadcast, loopback, everything I can type here. Now guys, understand one scenario. I have two router only, R1 and R2. Both are directly connected with one link. So this connection is point to point connection, as you all know. This connection is point to point connection, means because router 1 is connected with only one device through this link. Yes or no? This is, let's say, F0/0 of router, and this is F0/0 of router 2. So F0/0 of router 1 is connected with router 2 only. So connection is point to point. So here my network type should be what? Here my network type should be point to point. Okay, by default, if, let me take two router here, and let me do one thing. I am going to down these devices for now, turn off, because I have changed the configuration there, right? So that's why I have turned off the device. Now I am going to add two router. Number of router is 2. Let me connect the device, and let me turn on these two devices. Okay, on router 5 I am going to configure one IP, and on router 6 also I will configure one IP address. No, and let me configure router 6. Okay, enable config T interface F0/0, say no set, and IP address is, let's say, 12.1.1.1 255.255.255.0. Okay, now I am going to configure OSPF. So router OSPF 1 and router ID, let's say 1.1.1.1, and I'm going to enable it on interface basis. So IP OSPF 1 area, let's say 0. I have advertised it in area 0. Done. Now on router number 6, I'm going to configure IP, enable config T interface F0/0, say no set, and IP address 12.1.1.2 255.255.255.0. I've configured this IP address IP OSPF 1 and we can say area 0 and router OSPF 1 and router ID 2.2.2.2. Oh, do clear IP OSPF neighbor, to clear IP OSPF processor. Yes. Process number 1. Where I am doing mistake. Do clear IP OSPF process. Say yes. And let me set router ID now. Done. Both router will form neighborship. So IP OSPF neighbor. Done, guys. Who is neighbor? 2.2.2. Soon this neighbor will dawn. This is possibly dawn now. So there is one neighbor 2.2.2. State is in two-way. This is previous entry. Soon this entry will, router will remove this entry. Yes. Now you can see 2.2.2 is neighbor. State is full. And this router is DR. Guys, why we are using DR concept? What is the purpose of DR?
To minimize the number of adjacencies
Yes.
and advertisements.
So here we cannot reduce the number of adjacency, yes or no? There is only one adjacency between router 5 and router 6. We cannot reduce it. So DR and BDR is required or not? Unnecessary router will carry one more LSA, that is LSA2 in their database.
Yes.
So DR is not required here. Yes, everyone is thinking this. Am I right? If
Yes,
anyone
yes,
is
sir.
thinking
That-
that DR is required in this network, please let me know. Yes, Nirav. Is it required? DR is required or not?
So not required. You can change network type to point on both.
Yes. So as we already know the network type, when we will configure network type point to point, then there is no DR and BDR election. And we have two more options, point to multi-point and point to multi-point non-broadcast. But here we will not configure these two types of network as well. You will understand it later on when I will discuss point to multi-point network type. That why we cannot configure this type of network in this scenario. In my scenario, because in my scenario only two network is connected. Point to multi-point means one point is connected with multiple point. Like if router 5 is connected with multiple router on same link, that type of network is point to multi-point. Not this is point to point. So physical connection is point to point, so OSPF network type should be also point to point. Okay, and now if you will verify the network type on any router, so IP OSPF interface fast Ethernet and 0/0. By running this command, okay, output is, if you want to filter the output, you can type here command what? We can say network type and include network type only. It is not showing me. Let me check exact keyword. This is exact keyword now, so let me copy it, and this is how you can filter the output. So IPOSPF fast Ethernet 0/0 include and network capital N and capital T in type. You can see network type on this link is broadcast. Who have configured this network type broadcast on this link? System. This is automatic configuration on Ethernet link. Whenever you will enable OSPF on Ethernet link, network type will be broadcast. Done. Where is all other people? Fam, Vishnu, am I audible to you guys?
Yes, sir.
Yes, Michelle, come out. Raising hand. Do you have any query, brother?
No, sir.
No, okay. Yes, Mohan. Farhan, is it clear?
Yes, sir. Yes, sir.
Okay, Farhan. Yes, Mohan.
Yes, sir. It's clear, sir.
Okay. Now, network type is broadcast. Here I need to change network type. So to change network type, on interface F0/0, you will run command IPOSPF, then process number, after that network. Sorry, IPOSPF network. This is command, and then network type. So I want to set point to point over here, right? App configure point to point network type. So OSPF neighborship has gone down. Why? Because network type should match. Yes or no?
Yes.
So now if you will troubleshoot this network, that why there is no neighborship, so IPOSPF neighbor, how you will troubleshoot? How you will troubleshoot if there is no neighborship between router 5 and router 6? Again neighborship is up. Let's say if neighborship is not there, first of all you will run command show IPOSPF interface brief to check OSPF is enabled on how many interfaces. Then maybe you will check network type. You will check, definitely you will check, process ID, you are able to ping your neighbor router or not, or blah blah things.
Area configuration.
Area configuration. So those all configuration are here. So IP OSPF interface brief. Area, process ID, right? IP address and network type. Network type is point to point. So IP OSPF neighbor. Why neighborship is up? Can anyone tell me? Why neighborship is not down? Because here network type is point to point, and on router number 6, if you will verify here network type. So IP OSPF interface F0/0 and say include network type. Here network type is broadcast, but still neighborship is there. So we had not discussed any requirement like this in hello parameter. Or is it parameter, Nirav?
Sir, basically, because
and one more thing here, you can see date time. Date time is 37 seconds, and there is no DR and BDR. Now, this timer is increasing 30 seconds, and now it is resetting. See 36. Why? Here I have configured network type point to point. This side on router number ship network type is still broadcast. So here again, Nirav, we are able to see hello time is 30 seconds.
10.
Not 10. Yes. Hold on. Hello time is 10 seconds.
Dead is 14.
Yes.
So basically, neighborship is being formed because both
have passed from all state.
Yes.
So let me do one thing. I am going to run shutdown command and no shutdown command on fast Ethernet 0/0 shutdown and no shutdown. Now OSPF neighborship will come up or not? So IP OSPF neighbor access start full. Okay.
Yes, sir. Neighborship will be up, but they won't be forming any kind of adjacency. So basically, they won't be sharing any kind of LSS.
Let me create one loopback here. Here. Interface loopback 1 IP address 10.1.1.1 255.255.255.0 IP OSPF1 area 0. Let me take you to router number 6 and so IP route OSPF. So IP OSPF database. So IP OSPF database router 1.1.1.1. Nirav?
Yes, sir.
So OSPF neighborship can form with another type of
Different
yes
network type.
type.
Yeah, I got your point. Actually, there are some permutation and combination which is like with which the OSPF can still work
Yes,
if
and
they
while
don't match.
discussing OSPF neighborship parameter, also we had not discussed like network type should be match.
Yes.
Okay, now on router number 6 also I am going to change OSPF network type interface F0/0 IP OSPF network and point to point. Done. So IP OSPF neighbor, soon neighborship will come up. Okay, neighborship is full, and so IP OSPF interface F0/0 include network type. Network type is point to point. So is it clear, guys, in which scenario I need to configure network type point to point? When you will enable OSPF on serial link, then automatically by default network type will be point to point. Let's say if I will design one topology in GNS3, here we had discussed that whenever we are configuring OSPF, by default network type was broadcast. In this scenario, by default network type was broadcast, and here I have configured network type point to point. But by default, if you will enable OSPF on serial link, let me design one topology in GNS3 with serial link. Here I am going to make you understand one more concept. Okay, Nirav?
Sir, right now I just went through one of my old notes regarding
Okay.
OSPF. In that, actually, I had mentioned that what are the valid OSPF network types, which are, if not same, then also it will work. That one is broadcast, and other end can be non-broadcast, and one is point to point, and other can be point to
Point to
multi-point.
multi-point.
But here you did broadcast versus point to point. So
Yes.
there also, like, it will work even though the timers we need to adjust the timers, no sir, but then at any end, I
Timer
guess.
is fine. On router number 6, if I will set which type of network you want to set here? Point to multi-point.
No,
In
basically
which
you
scenario SPF neighborship will not work? What network type is?
uh, like uh, it should not work with point to point and broadcast. Actually it should not work, but how it is
No,
working, I'm
point to
confused.
point and broadcast, it's working fine. Fine.
But actually, in my notes, I have mentioned broadcast to non-broadcast will work properly, and point to point and point to multi-point will work.
Yeah,
But in
broadcast
these
and
two,
non-broadcast both are same or belongs to same category.
yeah, but in that we need to adjust the timers in this both scenario.
Yes,
But
yes,
here I am
exactly.
confused this particular part.
Point to point and broadcast is working fine. I also think so that it should not work. fine.
Actually, adjacent neighborship is
Let me
for
do one
many.
thing. Can
But
I turn on my real device? Let's see on real device it's working or not. Maybe this is because of simulation software.
okay, okay, okay.
I can, let me turn on the device, and till then I am going to configure this topology as well. Just give me guys 1 minute.
Okay, okay.
My gosh, I have not used my rack since long time and I forget IP address as well. Let me try. Okay, before that I am going to configure OSPF here in this topology.
Okay.
Here which link I am using? Serial link. So interface serial 2/0 say no set and IP address 12.1.1.1 255.255.255.0. Done guys. And router OSPF 1 and router ID 1.1.1.1. Exit interface serial 2/0 say IP OSPF say IP OSPF 1 area 0. So now you can check the network type. So IP OSPF interface F0/0 sorry not F0/0 S2/0 include network type. Here network type is
Point
point to point
by default.
by default. So on serial link by default network type is
Point to point.
point to point. Okay, now let me configure router 2 also. Config T interface serial 2/0 say no set and IP address 12.1.1.2 255.255.255.0 and router OSPF 1 router ID 2.2.2.2. And then I am going to enable OSPF on this interface IP OSPF 1 area 0. So if you are using serial link between two router, you don't need to change network type. So IP OSPF interface serial 2/0 include network type. Network type is point to point by default. So here we don't need to change network type, but if we are using fast Ethernet link, then we need to change network type manually. And so IP OSPF database, in the database also we are able to see only LSA1 because whenever network type is point to point, then DR/BDR election will not happen. Getting my point?
Yes, yes.
And here on this serial link, let me change the network type interface S2/0 say IP OSPF network and broadcast. See OSPF neighborship is going down. Okay. Debug IP OSPF packet and hello, or that we can say hello packet hello. There is no neighborship neither. See, it is sending hello message, but there is no neighborship. So IP OSPF neighbor. Oh,
Yes, sir.
neighborship is full. On all. Here also neighborship is full. That means, you know, network type point to point and broadcast are compatible with each other. They can form neighborship because here my network type is broadcast on router number 2 and on router number 1 my network type is point to point. OSPF neighborship is working fine. Let me try it on and see here. Okay, on serial link it is clear that we don't need to configure change network type because by default network type on serial link is point to point. That is fine. And we cannot use serial link, right, to connect a router with switch because switch is a multi-access device, right? And serial link is point to point link. So here, whenever you need to connect two devices only together, then you can use serial link. Okay, so actually we are using serial link to connect routers only. Done. And whenever we are configuring OSPF on serial link, so as I told you, router 1 will consider router 2 as their neighbor. So IP OSPF database, a router, and 1.1.1.1. It is saying 2.2.2 is one link. It will consider their neighbor as a link. Where it is? There are two links. One is 12.1.1.0 and one is 2.2.2.2. So actually it is considering their neighbor as a link. Can anyone tell me what is the benefit of it? Nirav? If router 1 is installing their neighbor as a link, so is there any benefit of it?
Basically, no particular benefit is there, according to me. Because any LSA, like any router, for creating a map, it will require link ID, that is network ID, that is link ID, then particular subnet mask, and
No,
the
see, this
cost.
is very important entry, Nirav. Okay, I will make you understand what is the advantage of it later, not now. Okay, so please
Okay.
keep this in mind because it is important. If I will forget, please remind me. Okay.
Okay.
Okay, so we had discussed the behavior of OSPF on serial link. Now let me try to configure it on real devices also to sure. Because according to me also, you know, oh, IP address is this one or something else? Yes, this is IP address. Great. Password is pm@123. What is password?
7 lakh.
Yes, it's PM123. Fine.
7 lakh.
So let me take access of router 1, R1, and this is R1. Let me clone the session and say PM123, PM123, R2, enable PM123 and clear line 19, and again I am going to say R2. This is access of R2. Let me take access of R1 also, switch 1 also, because both devices are connected through switch. So you know in rack, this is R2.
Yes.
In rack, how devices are connected?
Yes.
You know, have I discussed the topology, physical topology of rack? I think I have not discussed it till now. One day I will discuss lab topology also. Let me take access of switch 1. See, router 1 and router 2, both routers are connected with switch 1. Interface 0/0 of router 1 is connected with 0/1 of switch 1, and interface 0/0 of router. Interface 0/1 of router 2 is connected with 0/2 interface of router 2. Done. Like if I will design this topology here, so what I am saying that here I have one switch and router 1, R1, R2. This is 0/0 of router 1. This is 0/0 of router 2. This is 0/1 and this is 0/2. So I am going to don all other interface of switch except 0/1 and 0/2. So on switch I am going to run interface range f1/0/1 2, and I am using this type of ID, interface ID. So this is for stacking. We will discuss it later. Okay, first number is a stack number like fast Ethernet 1. This is a stack number, then slot number, and then interface number. So 0/1 to 24 I am going to say shutdown all interface, and I am going to up only 2 interface, that is f0/1 and 1 to 2, say no set. Now I am going to configure one IP address on router interface f0/0, say no set, and IP address 12.1.1.1 255.255.255.0. Done. I've configured the IP address, and so IP interface brief exclude unassigned, you can see, and so CDP neighbor also. In real time we cannot see neighbor devices directly like in EVNG or GNS3. So we can use this command, so CDP neighbor, to check router 1 is connected with which device. So here we are able to see router 1 is connected with switch 1 and switch 2. Switch 2 on f1/0. So I am going to down this interface also. Interface f1/0. I am not going to use this interface. f0/1. Which interface it is? Fast Ethernet 0/1. So interface f0/1 and say shutdown. Now if you will check so CDP neighbor, soon it is going to flush this entry. In so CDP neighbor you will see there will be only one entry. This router is connected with switch 1 on fast Ethernet 0/0. Done. Like this router is also connected with same switch, so CDP neighbor. Done. And now I am going to configure the IP. So interface f0/0, say no set, and IP address is 12.1.1.2 255.255.255.0 255.0. Now I am going to configure OSPF on router 1 and router 2. Let me delete this console switch. I'm not going to use it now. On router 1, let me configure OSPF by running command router OSPF process 1, then router ID 1.1.1.1. Now you are not able to see the topology, right? Because topology is in my rack, guys. I will make you understand this also, that how devices are connected in my rack. Then interface f0/0, say IP OSPF 1 area 0. This is completely real time. Okay, so there will be some command that we cannot run in simulation software. That's why we are using real devices, and sometimes output is also wrong in simulation software. Okay, so let me configure OSPF on router 2, OSPF 1, router ID 2.2.2.2, and then exit interface f0/0, IP OSPF 1 area 0. Now again you can verify the network type by running command, so IP OSPF interface brief include
Network type.
network type. So network type over here is where I have did mistake. Include network type. Okay, let me run like command like this. So IP OSPF interface brief.
Sorry,
OSPF
you
yes.
used brief, that's why pipe command did not work.
Yeah. So I can directly say here, so IP OSPF interface include, here I have touched this one, include network type. So IP OSPF interface brief network type. Okay, so IP OSPF interface fast Ethernet 0/0. By running this command, can we check network type fast Ethernet 0/0?
Yes.
And here also you want to exclude, so command is same. Then why it's not working? Include.
Sir,
Oh, include network type. Network type.
No, sir.
Not
pipe.
type is fine.
Pipe is missing actually. That's why that marker is showing. after 0/0 pipe symbol is missing, sir.
Oh,
Come on.
so network type is broadcast. That's why OSPF neighborship is full. So IP OSPF neighbor. Then I am going to change network type here. Let me set point to point. Interface F0/0 IP OSPF network point to point. So IP OSPF neighbor. Now Nirav, this is real devices, okay? So now we are 100% sure that broadcast and point to point are compatible to form OSPF neighborship. Okay? Because you can see neighborship is full. And it will exchange their database also on router number 1. Let me create one loopback, interface loopback 1, IP address 10.1.1.1, 255.255.255.0 and IP OSPF 1 area 0. On router number 2, also I am going to add one loopback to check IP address 20.1.1.1 255.255.255.0 IP OSPF 1 area 0 and ping 10.1.1.1 source 20.1.1.1. How many of you are saying that yes, it will work, ping will work here? Yes, Nirav.
So since it is showing full, then it should work.
Oh, ping is not working. So IP OSPF database. In the database, there is one network LSA also. Okay. And there is LSA 1 of router 1, LSA 1 of router 2. Let me open the LSA 1 of router 1. Router 1 is sharing this network. Yes, it's fine. And let me open LSA 1 of router 2. 20. So IP route OSPF. So IP route OSPF, we don't have any prefix in routing table. On router number 1. So IP OSPF, so IP route OSPF. We don't have any prefix. In the database, we are able to see the 20 prefix. So IP OSPF database. Here we are able to see the LSA 1 of router 2 and inside LSA 1 of router 2. So IP OSPF database router 2.2.2.2. Inside LSA 1 of router 2, we are able to see 20 prefix. Matrix is also fine. Link connected to a stub network. Yes, but router is not installing it in routing table. So IP route OSPF. So this is new concept for me. For me, it
Sir, I
is
guess,
new concept. Yes.
sir, actually, I think basically if we will look at hello and dead timer at both the interfaces, they will be
So
as
IP
per the
OSPF
network type,
neighborship,
correct?
then neighborship will goes down, na brother. So IP
So that
OSPF
is
interface brief. So IP OSPF interface F0/0. Hello timer over here is hello time. Guys,
10
see
and
this is the
40.
output of
Yes.
real time. This
Yes,
is
sir.
output
That is
of
also
real.
matching. Yes, that hello and dead timer is also matching. Okay. Yes.
Hello and dead timer is otherwise neighborship will goes down na
Yes.
for some time.
Then this is I need to search about this then.
Yes, I also need to search it. But okay, for now it is clear to you guys that whenever we have network type point to point and broadcast, neighborship is full, but router are not installing the routes in routing table. Okay. And on router number, here I am going to do one thing. Let me change network type on 0/0 IP OSPF network. Here also I am going to say now broadcast. Here network type is broadcast. So again neighborship has resynchronized, and so IP route OSPF. Now it is installing 20 prefix. Okay, if I will set any other network type, let's say interface F0/0 IP OSPF network, that side on router 2, I think I have not changed any network type, so it is by default, that is broadcast. This side, so IP OSPF interface F0/0 include network type. I know a few of you are feeling bored, not getting me broadcast, but don't worry guys, sometime it's happening. IP OSPF network, and let me configure any other network type here except broadcast. Let me configure non-broadcast. I have configured non-broadcast here. So again OSPF neighborship will resynchronize. Now OSPF neighborship is down. So IP OSPF neighbor. Now there is no neighborship. So non-broadcast and broadcast is not compatible with each other.
Yes.
There is no neighborship. Yes.
Yes.
This is the concept.
Yes, sir.
That whenever network type is different, then OSPF will not work properly. You cannot say OSPF will not form neighborship. Just say OSPF will not work properly whenever network type is different between two router. And if I will set any other network type, F0/0 IP OSPF network, and let me set non-broadcast as well. Let me set point to multi-point. Still OSPF neighbor is done. So IP OSPF neighbor. It is receiving hello message, but there is no neighborship. Okay, let me move to next network type in OSPF. So this is configuration of real devices. Whatever output you are able to see here, right? Output will be same in real time. Sometime in simulation software you will have less number of network type here, more number of network type here, but this is the real time configuration. This is real devices. Okay, let me close it, and let me take you again to EVNG, this topology. Guys, I am going to delete this one also, because I think it is clear to everyone in which scenario I need to use network type point to point. Yes or no?
Yes.
Clear? Hope it is clear to all. That whenever we will connect two router together, the network type should be always point to point. Make sure, maybe in real time, if you are configuring OSPF or anywhere, even you are practicing OSPF in GNS3 or EVNG, if you are connecting two router together, make a habit of changing OSPF network type. Here network type should be point to point. Okay, next type of network is, let me delete it. Okay, guys, one more concept, let me make you understand. Okay, it is clear that when two routers are directly connected, the network type should be point to point. And when more than two routers are directly connected in same network, that time network type should be what? Let's say here I have one switch, and this switch is connected with one router here also, and let's say here also. So in this scenario, what should be the network type? See, first of all, here DR and VDR is required. Yes or no?
Yes.
One router should become DR in this scenario. Otherwise, there are lots of adjacency. There are lots of LSA1 flooding. Okay, so we have lots of problem in this network. Done. So here we need DR and BDR. So keep in mind that whenever we will connect more than two routers in a same network, the network type should be broadcast. In this scenario, network type should be broadcast. Whenever we are connecting more than two routers in a same segment, same network segment, the network type should be broadcast. Is it clear? And if I will talk about the type of topology, guys, so actually, on the internet we have two types of topology. One is full mesh topology, and one is hub and spoke topology. Hub and spoke topology. Done. If I will talk about full mesh topology, means all branches, all routers are directly connected. See guys, if I am saying, if we are learning actually to connect multiple routers together, configure routing protocols there, it doesn't mean that we will place lots of router in a single organization. If anyone is thinking, let's say this is an organization XYZ. Inside this organization, let's say 500 users are there. I need only one router maximum here. Yes or no? With one router also I can design network. So connecting two router together, now we are discussing, underlay network. There are two types of network. One is underlay and another one is overlay. Underlay means basic connectivity, IP connectivity. And overlay means, see here, let's say this is one organization XYZ. Here I have one more organization ABC. Right? Here I have one main data center or headquarter in different location. So we have connectivity through ISP here. Through ISP, all branches are connected together. Okay. So you will understand later. We will configure one tunnel over here. We will configure one tunnel. Like I have router 1, router 2 and router 3. I have 3 router. On router number 1, I have one loopback 10.1.1.1. On router number 3 also I have one loopback 30.1.1.1. There is, let's say, OSPF configuration on all routers, and 10.1.1 is reachable with 30.1.1.1. Is it clear? Let's say we are running OSPF on all routers and this IP address is reachable with this IP address. Now guys, whenever this IP address want to communicate with this IP address, all router will involve in the communication. All router will involve in the process. All routers will use their CPU utilization. Yes or no? Because router 1 will forward traffic to router 2, router 2 will forward to router 3. This is how this user will forward traffic to this user. Like this, let's say here we have thousands of users. So whenever these thousands user will communicate with this user, all router will be in role of communication. But if you want that whenever this user want to communicate with this user, you can form a separate BGP neighborship between router 1 and router 3. That router 1 will directly forward traffic to router 3, not to router 2. Now, when this user want to communicate with this user, router 2 is not in role. We have escaped the router 2. Router 2 is not going to process any traffic. So this network, inside connectivity is underlay network and outer connectivity is overlay network. Let's say this is one branch here, this is one branch over here in different location, and this is ISP. Router is, this is ISP. And here I want to forward traffic through one tunnel interface. So first public IP address of this interface and this interface should be reachable with each other. That is underlay network. And if underlay connectivity is there, then you can configure one tunnel. And through that tunnel you can forward your traffic. That is overlay network. Yes or no? Clear, Neerav?
Yes, sir.
Am I right?
Yes, sir. Correct.
So if I will talk about the network topology, so mainly we have two types of topology. One is full mesh and another one is hub and spoke. Hub and spoke means let's say I have one topology here. Let's say router 1 is a headquarter router. Headquarter. This is a branch in Bangalore. What we can say, it is a branch. Let me bold it. Headquarter. And on this branch, let's say one LAN is connected. Which LAN? Let me create one LAN over here. That is, if you want to see that LAN also, I can show you the IP configuration. On router number 1, I am going to check the IP of loopback interface, and that is, let's say, LAN connected on headquarter. So IP interface brief. Loopback interface is 10.1.1.1. So here one LAN is, that is 10.1.1.1/24, not 10. This is one LAN network. Like this, hub quarter will have multiple network, and this is my branch offices. Let's say this is branch 1 in Delhi, and let's say this is branch 2, and branch 2 have also one network, that is, let's say 20.1.1.0/24, and I have one more branch, that is branch 2, and on branch 2 I am running some different network. 2 network is 30.1.1.0/24, let's say. Done. And this is not switch. Consider this is ISP. Through ISP, now you don't need to focus that how ISP is connected, right? So I have replaced ISP with one switch. That means between, branches, we have ISP, and all public IP address means the IP address which is running on this interface should be reachable with this interface. This is responsibility of ISP. That's why I have placed one switch over here. Done. So guys, see, if I want to connect all branches together, so I need to connect headquarter to branch 1, headquarter to branch 2, and then branch 1 and branch 2 together. Yes or no? Here all routers are directly connected with each other. This is full mesh topology. Full mesh topology. Okay? Done. Full mesh topology means all routers are directly connected with each other. All routers are connected with, like router 1 is connected with both routers, so router 2 and router 3. Router 2 is connected with both router 1 and router 3. Getting my point? And whenever network type is full mesh topology, what I am saying, whenever network type is full mesh topology, then we should use network type broadcast and non-broadcast. Non-broadcast. These two types of network, these two types of OSPF network is perfect for full mesh topology. Like if you want to connect two routers together, you should use point-to-point network type. If you have multiple routers in a same segment, then you should configure network type broadcast. And now your network type is full mesh, then you should configure network type broadcast or non-broadcast. Here we will implement both network type, and you will see this network type is working fine in this domain. But see, this is ISP, right? So when we are requesting for connectivity between branches to ISP, actually guys, we need to create virtual circuit here, and for this virtual circuit we need to pay to ISP. So sometime it is not necessary that you will create virtual circuit between all branches. Now you can see I have virtual circuit between branch 1 and headquarter. I have virtual circuit between branch 2 and headquarter, but I don't have any virtual circuit between branch 1 and branch 2. So my network, my topology is, see, there is connectivity between headquarter and branch office, and headquarter and branch office 2. Now if these headquarters want to communicate with each other, if these branches will communicate via headquarter, yes or no? Because there is no any connectivity between branch 1 and branch 2. Am I right? Tell me guys, is it clear? Now there is no connectivity between branch 1 and branch 2. Okay, Nirav?
Yes, sir. This is hub and spoke.
Yes, this is hub and spoke, because my hub router means headquarter routers are connected with a spoke, means branch office. A spoke means branch 1 and branch 2, a spoke 1 and a spoke 2. So this type of topology is hub and spoke topology. Hub and spoke. And whenever my topology is hub and spoke, then you should configure OSP of network type point to point and point to point non-broadcast. So we can use these two types of network type. Now let me implement it very quickly, okay? So hope it is clear to you now that in which scenario we need to use which type of OSPF network. Done, guys? Okay, now question is, if I will configure non-broadcast network type in full mesh topology, then what will happen? If I will configure, sorry, point to multi-point, then what will happen? Can anyone imagine? In full mesh topology, if I will configure network type, this is, let's say, full mesh topology. Here if I will configure network type point to multi-point, then what problem will occur? See, whenever network type is point to multi-point, then DR-BDR election will happen. Yes or no?
No.
No. When network type is point to multi-point, then DR-BDR election? No. Is DR and BDR required, guys, in full mesh topology?
But no, BDR won't be required.
DR-BDR is not required. So when we will configure it, then you will see there will be some problem. If you are not able to imagine, no problem. Neither are you able to imagine what problem will occur if I will configure network type point to multi-point in full mesh topology?
Sir, if point to multi-point is configured, then by default it will behave like point to point only. So, but with different IP address, because they are not in the same subnet.
Okay.
So basically, DR-BDR is not required. But say for example, if we want, then we can go ahead with this particular.
Brother, see here one thing. Neighborship is in point to multi-point. Point to multi-point neighborship is static or dynamic?
Yes,
dynamic.
dynamic. Yes.
Here static neighborship is static. So actually you have to form neighborship with hub branches also. So we don't have problem there also. No. I was thinking, something else. Yes, Nirav. If you will set non-broadcast network, it will stop sending multicast hello message. Whenever we will configure a network type non-broadcast, so it will stop sending multicast hello message. Means it will not support broadcast and multicast. By default, routers send hello message on what address?
224005.
005. Let me do one thing. Let me implement OSPF. I think OSPF is already running here. I don't need to do anything. Let me check. So IP protocol. Yes, routing protocol is running, and so IP route OSPF. I don't have any route, so IP OSPF interface brief. Here we have configure a network type on loopback interface is point to point. So first of all, let me correct it. Interface loopback 1, IP OSPF network type loopback. What happened? IP OSPF network. Okay, we don't have any option to configure network type loopback here. So I need to say IP OSPF network type, and which network type I have configured here? Point to point. So I'm going to say no. Automatically OSPF network type will become loopback. So IP OSPF. So IP OSPF. Yes. So IP OSPF interface brief. You can see network type is now broadcast. Okay. Now let me check configuration of router 2 also. Enable. So IP protocol. Oh, I'm not running any routing protocol here. It's so IP interface brief. So IP address is running over here. It's fine. Let me create the loopback interface loopback 1 and say IP address is 20.1.1.1 255.255.255.0. Exit router OSPF 1 and router ID 2.2.2.2. Exit interface F0/0 IP OSPF 1 area 0 and interface loopback 1 IP OSPF 1 area 0. Done. R2 configuration. So IP OSPF neighbor and so IP route OSPF. So it have received this network. Done. Now let me configure R3. Enable. So IP interface brief. So loopback interface. Okay, on loopback interface I need to correct the IP interface loopback 1 and IP address is 30.1.1.1 255.255.255.0. Exit, and I think rest configuration is fine. Router OSPF 1 and router ID 3.3.3.3. Interface range F0/0 and loopback 1. IP OSPF 1 area 0. By default network type is
Broadcast.
by default network type is broadcast, and on loopback interface by default network type is loopback. Okay, now so IP route OSPF. So you can see it have received 20 network and 30 network, right? And so IP OSPF database, and you can see there is LSA1 of all daughters, daughter 1. So if network type is broadcast and this is my full mesh topology, OSPF is working fine. Yes or no? OSPF is working fine. Branch to branch communication, branch offices can communicate directly, because see here, so IP route OSPF, next hop IP address is 192.160.10.3, means it can directly forward traffic to router 3, not to R1 then to R3. So there is direct connection. This is full mesh topology. So full mesh topology, in full mesh topology network type broadcast is working fine. Now I am going to configure network type what? Non-broadcast. Configure terminal interface F0/0 IP OSPF 1 and network. IP OSPF network non-broadcast. Let me copy this command and I am going to run this command on all other interface. Let me take you to router 2, interface F0/0. Done. Let me run it on R3. Interface F0/0. Done. app configure network type.
Non-broadcast.
So what is problem here? Now can I ping? Branch office can communicate with each other. OSPF neighborship is down. So IP OSPF neighbor. We don't have OSPF neighborship. Can anyone tell me why OSPF neighborship is down here? The reason is
So network
Okay.
type mismatch.
here I am going to capture the link, let's say fast Ethernet 0/0, or let me do one thing. On router number 1 I am going to debug OSPF, debug IP OSPF, or let's say hello message only. It will send hello message after which interval of time?
10.
But it is not sending any hello message. So IP OSPF interface brief. So OSPF is enabled on this interface and this interface. Here network state is waiting.
Good.
On other router, let me verify. So IP OSPF interface brief. Waiting. Why? Because you have configured network type what? Non-broadcast. And this interface, so IP interface fast Ethernet 0/0. This interface have joined these two multicast group to share, to send hello messages. Yes or no? But we have stopped the multicasting feature here. We have set network type what in OSPF? Non-broadcast. Non-broadcast means multicast messages are also not allowed. So that's why here we need to configure what? See, network type broadcast. Static neighborship, yes. Dynamic neighborship, no. Here we need to configure static neighborship. Remember static neighborship of EIGRP. In EIGRP, you have to run router EIGRP AS number, after that neighbor command on router number 1 also and on router number 2 also to form EIGRP static neighborship. But in OSPF, just you need to run this command on router 1 only. If you will tell to router 1 your neighbor is 2.2.2.2 or IP address of router 2, then you don't need to configure static neighborship on router 2. Automatically a static neighborship will form. Let me show you. On router number 1, I am going to say. So remember, if network type is, sorry, if my topology is full mesh, and then if you are configuring network type non-broadcast, broadcast is working fine. We don't need to touch the configuration in case of broadcast. But if my network type is non-broadcast, then we need to configure a static neighborship. Here I am going to say router OSPF process ID 1 and then neighbor. IP address of neighbor 192.168.10.10 or something else. Let me check. So IP interface brief. Yes, 10.2. 10.2. Now soon OSPF neighborship will come up. Done. Wait. So IP OSPF neighbor. State is attempt. For the first time we are able to see attempt state. So when OSPF network type is non-broadcast, then we have discussed that we have one more types of state, that is init or attempt. So instead of init, here you will see attempt state. Okay, and debugging is on, that's why we are able to see the log message of hello. So say all. And now you can see OSPF neighborship is fine between router 1 and router 2. So IP OSPF neighbor done. And so IP route OSPF, it have installed this network. Now let me tell to router 1 about router 3 also. Router OSPF 1 and neighbor 192.168.10.3. So OSPF neighborship will come up with router 1 and router 3 also. Now there is neighborship between router 1, router 2, router 1, router 3, but there is no neighborship between router 2 and router 3. So let me configure, let me tell to router 3 also. Your neighbor is router. Either I can configure it on router 3 or on router number 2. Router OSPF 1 and neighbor. What is the IP address of R2? 192.168.10.2. Done. Here when network type is non-broadcast, then DR and BDR election is yes. DR and BDR election is yes, yes or no. So here one router is going to become DR. And now guys, if by mistaken, okay, wait, first of all let me show you the R1 routing table.
10 to 15 minutes saving will
So IP.OSPF. So you can see router 1 have installed these prefix, both prefix. So IP.OSPF neighbor, who is DR? 3.3.3.3. Router 3 is your DR. So all router 2 and router 1 will share their database with router number 1. And on router number 2, let me check routing table. So IP route OSPF, it have installed 30 prefix, yes. And next up IP address is okay. Done guys. So now network type non-broadcast is also working fine. If you want to communicate between branch offices, ping 30.1.1.1 and source is 20.1.1.1. So there is reachability. Trace route 30.1.1.1 and source 10.1.1.1. Source 20.1.1.1. So it is router 2 is forwarding traffic directly to router 3. Yes or no? Done. So till now we have discussed implementation of broadcast, point to point broadcast and non-broadcast. In next class I will show you which type of network, point to multi-point and point to multi-point non-broadcast. So in full mesh topology we can, yes.
So basically R1, R2 and R3 were in the same subnet, correct? 192.168.
Yes.
Okay.
In real time, you know, you will have reachability like here. So let's say IP address is 1.1.1.1. Here IP address is 3.3.3.3. So your this IP address and this IP address will be reachable with each other.
Okay. But those are not in the same subnetwork. So basically, this will be.
So what will happen here? You will configure one tunnel, na?
Yes.
Tunnel source and tunnel destination will be in same subnet. Tunnel source and tunnel destination will be in same subnet. You will not configure OSPF on this WAN link, brother. We will configure it.
I got on this particular tunnel.
Yes.
With the help of tunnel, they will exchange all the LSs.
Yes. Actually, you know, these are the part of CCNP, but at the same time, I am considering CCN and CCNP. So actually, we are discussing OSPF, but we have not discussed the tunnel, these things. So maybe for some people, these are confusing. But time to time, we will connect everything together. Okay?
Yes. Okay, sir.
Any doubt?
No doubt right now. And
Okay,
sir.